Now I'm going to show you just a few quick practice problems. So feel free to pause me, try the problem on your own first, and then check your answer as you go. So the first problem says, find the radius of a circle if a 16-unit chord is 6 units from the center of the circle. So I drew in the chord, we can call it AB if we'd like, and I drew in the center of the circle. Remember, we just said before that when we're talking about the distance from the center to a chord, that's referring to the perpendicular distance. So if this whole chord is 16, and now I have this line that's coming in and is perpendicular to it, if I extended that line, it's really just a radii. So I know that each of these pieces are going to be 8 and 8 if the whole thing is 16. So now we have to find the radius. So I'm going to draw in my radius right there. You'll notice that I just created a right triangle. So I now need to use the Pythagorean theorem to find my hypotenuse. So if I do 8 squared plus 6 squared equals c squared. Some of you might know your Pythagorean triples by now. This is really a 3, 4, 5. So I can solve for the radius and you get 10. The second one's very similar. Again, they're giving me circle O. They're telling me that AB is 8. So since this is perpendicular, we know that each of these pieces right here are going to be 4 and 4. And now it's a 45, 45, 90. So that goes back to chapter 9. So if I want to find OA, I know that the legs are congruent. They're both 4. And then the hypotenuse is 4 radical 2. So OA is equal to 4 radical 2. Lastly, I threw this one in for fun because you know I love fun math problems. It's a system of equations problem. So we have to find the radius of a circle in which a 120-meter chord is 14 centimeters closer to the center than a 104-centimeter chord. And the diagram's not to scale. So just see if you can try this on your own first. Pause me, and then I will go through it. So I just started filling in. I know that this one has to be the longer chord because the closer you are to the center of the circle, the longer the chord you are. The further out you are away from the center, the smaller the chord. So I drew in my own radius, and I drew it in such a way that it was perpendicular to the chords, which means that if a radius is perpendicular to a chord, it bisects it. So that's where these 52s and 60s come from. So now I have to use the part where it says that the 120-meter chord is 14 centimeters closer to the center. So that means I could actually label, this is a distance of x, and since this is 14 centimeters closer, this one must be 14 centimeters further away. So I can label this one x plus 14. And that's referring to this whole thing right here. So this piece is just x. This whole thing is x plus 14. So I actually really have 2 sets of right triangles in here. Here is the first one. So if I draw in this radius, here is that first right triangle. So I'm going to write an equation for that. And I'm going to label this r because that's what we're trying to find. We're trying to find the radius. So I can say that x squared plus 60 squared is equal to r squared. That is my first equation. So I have 2 variables, so I'm going to need a second equation. The second equation is coming from, I can draw in another radius right here. I'm also going to call that r. And that is this big triangle right here. So again, I know this whole thing is x plus 14, so I can say x plus 14 squared plus 52 squared equals r squared. So I'm just using the Pythagorean theorem. So they're both equal to r squared, which is great because now I can just use substitution. I can say x squared plus 3600, I'm just going to simplify as I go, equals x squared plus 28x. And then if we do the 14 squared plus the 52 squared, we'll get 2900. What's nice about this is the x's will cancel. I could bring the 2900 over to the other side. So subtract it, I get 700. And then when I divide, I'm going to get 25. Now, remember, I'm not trying to find x. I'm trying to find the radius. So my last step is I'm going to plug it in. I'm going to plug it into the simpler one and do 25 squared plus 60 squared equals r squared. And when you end up solving that out, you end up finding that 65 is the radius. So use these examples to kind of guide you as you're doing your homework. And if you have any questions, I'll see you on Google Meets.